Now we'll have the discussion on the Maxwell's equation. In the previous lecture, we have derived the Maxwell equation from the Ampere's law and Faraday's law. And now we will derive the Maxwell equation from the electric Gauss law and magnetic Gauss law. Okay, first we will start with the electric Gauss law. Okay, and the equation indicates that the flux coming out of a charged body is equal to the amount of charge enclosed. Therefore, phi is equal to q. And we know that from Gauss law, phi is equal to surface integration of d. And this indicates the total flux leaving the surface can be obtained by the surface integration. Okay, and this can be defined as surface integration of d is equal to charge enclosed on that path, that is q. And we know that the volume charge density can be defined as the volume integral of rho v is equal to q. Okay, and for q I am going to substitute surface integral of d. Therefore, surface integral of d dot ds equal to the volume integral of rho v. Okay, by divergence theorem, this can be defined as surface integral of d dot ds equal to volume integral of del dot d into dv. Okay, and for d dot ds, substitute rho v dot dv. Therefore, the volume integral of del dot d is equal to the volume integral of rho v. Okay, cancelling the integration term and dv on both sides, and finally obtain del dot d is equal to rho, that is the total electric displacement through the surface enclosing a volume is equal to the total charge within that volume. Okay, and this is the Maxwell equation from the electric Gauss law. And second, we are going to discuss about the magnetic Gauss law. And the magnetic Gauss law states that the total magnetic flux through any closed surface is equal to 0. Therefore, phi is equal to 0. The surface integral of b dot ds equal to 0. And by divergence theorem, we know that the surface integral of b dot ds equal to the volume integral of del dot b into dv. Okay, here b dot ds equal to 0. Therefore, volume integral of del dot b into dv is equal to 0. And finally, we obtained that keeping the del dot b is equal to 0, and this term cannot be equal to 0. So I am keeping del dot b is equal to 0. And this is the net magnetic flux emerging through any closed surfaces 0. And this is the magnetic Gauss law. And this is the Maxwell equation that derived from the magnetic Gauss law. Okay, so far we have discussed about the Ampere's Maxwell's equations, Faraday's law, Gauss law for electrostatics, and Gauss law for magnetism. Yeah, thank you.